All right, so in section 5.1, we're talking about quadratic functions. This is actually the second recording I've done. I did the whole thing with no sound on, so that was cool. Anyway, so we're talking about quadratic functions in 5.1, and we're going to start out by discussing the graphs of quadratic functions. And so basically, this is just a U-shaped curve called a parabola. It's something that we should already be familiar with, but you'll need to know all of these words in red. And so some of the important features of this type of functions graph is the vertex is one, and that's located here. It's just kind of the turning point, the minimum or the maximum of the graph. And we also need to know about the axis of symmetry. It passes through the vertex and just kind of is a symmetry line or cuts it in half for that parabola. We're familiar with the y-intercept. That is where the graph crosses the y-axis. There's the y-intercept for this one. And then also the x-intercept. And this is where the graph crosses the x-axis. And we have other names for these that I'm sure you're familiar with: roots, solutions, and zeros. And so we'll primarily be talking about those features. So number one, given a graph, let's identify those key features on the graph. And so first up, we'll determine the vertex. And so the vertex is going to be located right here at this minimum of the graph. And the vertex is given as a coordinate. And so this, it will be 3, 1. Then next, let's look at the axis of symmetry, which passes through the vertex and actually just is the symmetry line for this particular graph. And so the axis of symmetry is reported as a line. And so I'll abbreviate axis of symmetry. It's always going to be x equals, if we're talking about functions. And so this will be x equals 3 in this case. Notice the 3 here is always going to correspond to this 3 here. They'll always be the same. And then let's look at the y-intercept, and that is going to be here and also should be reported as a coordinate that's located at 0, 7. Now for this particular graph, there are no x-intercepts. There won't always be some, and we'll get more into that later in this section or later in the chapter, but there are no x-intercepts for this particular graph because it does not cross the x-axis. The second part of section 5.1, we're going to connect the graph to its equation. And so we're going to talk about two primary forms of a quadratic function and its equation. And the first type, which you'll need to know the general form of a quadratic, and that is written as some number a times x squared plus some number b times x plus a constant c, where those numbers a, b, and c are real numbers, and a is equal to or not equal to 0. And one of your questions in your problem set says, well, what would happen if a was 0, and why is that not allowed? But we'll think more about that later. Some important features that we can tell about the parabola or the graph of the quadratic function from its equation. First, if a is less than 0, then the parabola opens down. And remember, for a number to be less than 0 means it is a negative number. If a is greater than 0, then the parabola opens up. In other words, if a is positive, right? Because being greater than 0 indicates a number is positive. We can define the axis of symmetry by x equals negative b divided by 2a. And we just pull those numbers out of the function and plug them into that formula. The solutions of the equation are given by x equals negative b plus or minus square root of b squared minus 4ac over 2a. And you may recognize this as the quadratic formula. And then the formula for the vertex given the general form, is going to be a coordinate, and the x part of the coordinate is negative b over 2a, and the y part of the coordinate is f of negative b over 2a. So it's just plugging that x coordinate back into the function itself. So in example 2, we're going to find the features of this parabola when given the general form. And so even though, like, we'll see the graph in a moment, the skill you need to get here is how to find all of these features without a graph. And so the first thing we want to look at is that A is equal to 1, B is equal to 4, and C is equal to 3, based on the definition of the general form that we saw here. And then we can use A to determine if the parabola opens up or down. So in this case, A is greater than 0, it's positive. So the parabola is going to open up. That's one feature. And then the next thing we'll want to find is the axis of symmetry. Axis of symmetry that's given by x equals negative b over 2a. And so we're just going to plug that in for what we have here. So we'll have negative 4 divided by 2 times 1, which will be negative 4 divided by 2, which is just negative 2. And so the axis of symmetry here is going to be x equals negative 2. And the next thing we want to find is going to be the vertex. So the next piece here is the vertex, which, if you remember, is defined as the coordinate negative b over 2a for the x value of the coordinate, and f of negative b over 2a for the y value of that coordinate. But, we just found this x value here with the axis of symmetry, so that part's already done. And all that's left is for us to plug that back into the function to get the y value. And so that would be f of negative 2. And so that would be negative 2 squared plus 4 times negative 2 plus 3. If we do all those calculations, we'll see that that's equal to negative 1. And so that's the y value for our vertex. And so now we also have the vertex. And then the next thing we want are the y-intercepts. Y-intercept, which, remember, to find the y-intercept, we plug in 0 for all the x's. So if we just find f of 0, we'll find our y-intercept. And so that'll be 0 squared plus 4 times 0 plus 3. And so that's just going to give us 3. And the y-intercept is reported as a coordinate. So that's going to be 0, comma 3, and there's our y-intercept. And then we're going to find the x-intercepts. And so remember from our little bulleted list earlier, the x-intercepts are given by x equals negative b plus or minus square root b squared minus 4ac all over 2a. And so just taking those values from above, we'll have negative 4 plus or minus b squared, which is 4, minus 4 times a times c, all over 2 times a. And so you're going to end up with two answers here. One coming from this positive or plus, negative 4 plus all of this divided by 2, and then the other one will come from this negative 4 minus all of this divided by 2. Excuse me. And then you'll see that the plus kind of version of this, when you do the negative 4 plus, you're going to end up with negative 1. And when you do the negative 4 minus, you're going to end up with negative 3. And so the two x-intercepts, also reported as coordinates when I'm asking for an x-intercept, is going to be negative 1, 0, and negative 3, 0. So there are all of the features of the parabola and how to find those. And then we can kind of look here and confirm everything that we've just seen. There's the vertex, the x-intercepts. Here is the y-intercept. And then this red dashed line is the axis of symmetry. So moving on, some more vocabulary words and another form of a quadratic function, which is called the standard form. Looks like this right here. So it's a times quantity of x minus h squared plus k, where h comma k is the vertex. And because we can see the vertex so easily just with h and k, we do also call this the vertex form of a quadratic function. You'll be expected to know this one as well. So finding the vertex and determining if it opens up or down from this form. Now, again, even though you can see the graph here, you'll need to be able to do this without seeing the graph. And so A, in this case, let's go ahead and write down everything. A is going to be -3. H is going to be -2, and K is going to be +4. The reason this is a -2 is because if you notice, our formula for this is written as x minus a number. And so to get that positive, we would actually end up having to write minus -2 to match this minus here in the formula. And so if you, it effectively changes signs. So if you see +2, you're gonna know that h gonna have to be negative. So to pull all those out, first thing is because a is less than 0, this is gonna open down. So that's the first thing. And then we can find the vertex just based on pulling the value of h and k out. So the vertex will be located at h comma k, or -2 comma 4. And now we've got everything we need. Looking here, the standard form is also used to see what transformations were applied. And so that would be, with that negative out front, it would reflect over the x-axis. We'd have a vertical stretch by a factor of 3 from that a value multiplied in the front. And then we would see a left 2 horizontal shift and an up 4 vertical shift. And so we also call this the transformational form, but I won't require you to know that. So the next example is given a graph. So in this case, I would give you a graph and I want you to write the general form. And so remember vocabulary, the general form is like this. It's the ax squared plus bx plus c. And so when you're doing this, you want to always start by writing the vertex form, because you can see that form from the graph, or also called, remember, the standard form. So that's going to be kind of a way to get to the general form, but we're going to start by writing the vertex form, which is f of x equals a times x minus h squared plus k, where hk is the vertex. So we need to find the vertex first. So let's find the vertex from the graph, and it's located there. That's going to be -2, -3. So right off the bat, we know that this is h and this is k. So we'll go ahead and write it with those things plugged in. And so we'll have a x plus 2 squared minus 3. And so the only thing I don't have that I need is this a value. And in order to get that, I'm just going to take another point from the graph that's not the vertex. It doesn't matter which one you choose, as long as it's one that you can clearly see. And I'm going to choose that one. It doesn't have to be the y-intercept, but I just chose that one just because I did. So we take this other point, and we know that this is an x and a y, and then we're going to plug that in here and solve for a. So f of x equivalent to y, so that's -1 equals a times 0 plus 2 squared minus 3. And then we're going to, again, solve for a. So this will be -1 equals 2 squares 4a minus 3. Adding 3 to both sides, I'll get 2 equals 4a. And then ultimately 2 divided by 4 equals a, which will end up giving us 1/2 for our a value. And then we can just go back and plug that in to our vertex form. So let's go back up here. So that's f of x equals 1/2 x plus 2 squared minus 3. And so now we have our vertex form here. All right, so this is our vertex form. And how we get from the vertex form is we expand and then simplify. So let's do that real quick. So let's say, all right, so this would be f of x equals 1/2 times x plus 2 times x plus 2 minus 3. I will go ahead and multiply those two together. That'd be x squared plus 4x plus 4 minus 3. Distribute the 1/2. 2x plus 2 minus 3. Combining like terms, I'm going to end up with my general form. 2x, 2 minus 3 is -1. And so there is our general form. And so we're done. So always start with the vertex form when looking at a graph, because it's much easier to use the features that you can see. And then, just kind of get the vertex form and expand it to the general. So now I give you a chance to try that. So if you want to pause the video and come back to see if you got the right answer, then I encourage you to do that right now. Zoom in a little bit so you can see the numbers. All right, so the general form you should obtain here is -2x plus 12x minus 14. And if you didn't get that, then of course, come ask me when you see me, and we can work it out what happened. Example number 5 says to find the vertex of this function, then rewrite the equation into the standard form, which is very similar to what we just did, except for we're going to write it in the standard form, which is the vertex form. So this is where I'm trying to get f of x equals a x minus h squared plus a. And so remember, to get the vertex from this general form, the vertex is going to be given by the coordinate -b divided by 2a and f of -b divided by 2a. It's okay, baby.
I'm just getting like a candy because I'm putting it on my teacher's gift card.
That's very sweet, baby. All right. All right, so if we're looking here, I really like to write these things out. Maybe this won't be helpful for you, but I do find it helpful. A is 2, B is -6, and C is 7. And so now it's just a matter of me plugging it into this formula. So -b over 2a, -6 would be +6, divided by 2 times 2. So that'll be 6 over 4, which will be 3 over 2 for the x coordinate of the vertex. And then I'm going to go back and find f of 3 over 2, just plugging it in there. And you'll obtain 5 over 2. And so now that I have the vertex, and I skipped all these steps because I've shown you how to plug that in several times, and you can do that with your calculator. So you do obtain the vertex after that process of 3/2 and 5/2. And so at this point, the important thing to note is that this a that I pulled out of here is the same as this a. That's why we use the same letter. So we don't have to do anything to find that except recognize that fact. And so now we'll just plug in h and k for the vertex, and we'll be all done in our standard or vertex form. So that's done. But the key thing here that's new is recognizing that a is the same in all of these 3 places. So now you try. This one's asking you to find the vertex and then rewrite in standard form, which is exactly what we just did. And then this one's asking you to go a little bit further and to write that in both the general and the standard form. So if you want to pause and try those and then come back and double check your answers to see how you did. All right, so this first one, you should have found a vertex of -2, 4, and the standard form is going to be 3x plus 2 squared plus 4. Okay, and then for the next example, you should find the general form, just rewriting in the correct order, descending exponent order. That would be x squared minus 6x plus 13.
This is the data cut.
Baby, that's so sweet. You even drew an extra picture and put candy on there. That is so nice. I love that. Can I finish doing this?
I have 3 teachers, so I'm gonna have to make another one.
That's fine.
But I don't have a card.
Well, we'll get you one, okay?
But I don't have a Halloween card.
Well, we'll get you one.
I need the exact same one, or else it won't be fair.
I agree. We'll get the exact same one, okay? Okay, baby. Lily, will you shut my door, please? I'm almost done.
I have Miss Hewitt.
Okay. We'll get it, baby.
Miss Brennan and Miss Till.
She's so sweet. I'm sorry. All right. And so then moving on to the vertex or standard form, it's going to be x minus 3 squared plus 4. So again, if you have questions about those, ask me during class. So the last thing we'll cover in 5.1 in the lecture today, you hear that crunching? That's my dog chewing on a water bottle. Sorry, the perils of recording lectures at the house. So we're going to talk about the domain and range of a quadratic function. And so the quadratics always have a domain of all reals. And you can write that in the set notation with the bolded R, or in the interval notation. And that's because there are no domain restrictions, right? There's nothing we have to take out because it gives something undefined. So that's an easy one, always all reals. And then to find the range, being that we know that a parabola either looks like this or this, it's going to have a minimum value if it opens up and a maximum value if it opens down. And that's just k, right? So that's just the y value of the vertex when it's given as hk. That's just the one that addresses kind of the vertical component because it's the y. And so these are the formats for the range depending on if your parabola opens up or down. And this actually should be negative. So find the domain and range of this function. Now this one's given in the general form. And so that's problematic because, you know, we can't readily see the vertex here. So we are going to have to rely on the formula. And recall the formula for the vertex in the general form is negative b over 2a, f of negative b over 2a. And so we'll start out by just defining a, b, and c just to make things easy. So that's 9 and c is -1. And so then we can just apply the formula. So negative b over 2a is going to give me 9 over 10 for the x value of the vertex, 9 over 10. And then we would just need to calculate f of 9 over 10 for the y value of the vertex. And you'll obtain that that's like this crazy number right here. But that's okay because our calculator can help us whenever we need it. So that's 61 over 20. And so again, this is h comma k. And so this is what we're looking for the range. And so let's determine if this is an opening up or down parabola. And remember, it depends on A. And so A is less than 0 here, so it's going to open down. So to give you a visual, if it's opening down, the graph's going to look like this. And so this maximum value right here is going to be located at 61 over 20. So your range is going to be from negative infinity to 61 over 20 inclusive. And if you like using the formula, it's exactly this one right here. So this is K, and so we apply that here. And so now you give it a try. Notice the first example, I give you the general form where you can't see the vertex. But in this second one, I give you the standard or vertex form where you can see the vertex. So the second example is a little bit easier. So I'll give you a second to take a look at that. And pause the video, then come back and see how you did. So, all right, so this one you should get negative infinity and negative 1.438 inclusive. And then finally for this example, you should get 8 over 11 inclusive to positive infinity for your range. And of course the domain of both should just be all reals since they are quadratics. And so this is the range. All right, I hope that helped. So for now, we'll stop. If you're looking for the 5.1 exercises, you do want to work on 1 through 65 odd. And we'll work through the remainder of those exercises with the second lecture for the next time we meet on Wednesday. So I hope this was helpful, and I'll see you guys on Monday.